my dear student, I'm Saktwala from Educators. I will be with you in physics for Form 5. And today we are going to proceed with our discussion on our topic of properties of matter for the subtopic of the surface tension. This will be the last session for our subtopic of surface tension. So, my dear student, let us proceed with our discussion. Today, we are going to see some examples related with what we learned on our subtopic of the surface tension. Before we proceed here, we are supposed to know where we ended on the last session. On the last session, we tried to see how can we get the height of the capillary tube. We tried to derive several formulas. The first formula said that for the concave meniscus, we obtain the height of the tube, which is equal to 2 times the surface tension, then we times it by the cosine theta. We divide it by the density by the density times the GR. That is what we demonstrated on the last session. Finally, for the convex meniscus, we demonstrated by saying that the height of the tube must be equals to 2 times the surface tension cosine theta. Then we add it by the GRH. The G density H. That is what we demonstrated on the last session. So for our today's discussion here, we are going to see the example number 6.7, which is say that the radius of a capillary tube is equal to 0.25 millimeter, and it is inserted vertically in a liquid whose density is equal to 80 exponent 2 kilogram per meter cube. Now, and the surface tension is equal to 3 exponent negative 2 Newton per meter. If the angle of contact is 72.5 degree, now demonstrate or determine the height of the height to which the liquid will rise in the tube. This is what we have been asked on our question here, my lovely students. First of all, let us try to summarize our equation or our example together. We see that imagine we have the narrow tube or we have the capillary tube. That capillary tube, my dear student, having the diameter, having the radius of having the radius which is equal to 0.25 millimeter, but it is inserted vertically. After being inserted vertically, I tried to produce the density which is equal to 80 exponent 2 kilogram per meter cube. Now, how can we determine the height of the liquid if the angle of contact is equal to 72.5 degree, and also the surface tension is equal to 3 exponent negative 2. Now, how can we get the height of the liquid that could make the liquid to rise in the tube? So before we solve this questioning, the key point that we are supposed to do now is to summarize the data that we have on our equation. On our example, we have we have been given the radius of the tube. Also, we have been given the surface tension. Finally, the angle of contact, and also the density. Now, how can we get the height? That is what we have been asking. So first of all, let us recall the formula of obtaining the height for the capillary tube. Formula yetu inasemaje? Our formula say that if the height of the liquid in a tube must be obtained by taking the 2 times the surface tension, then we times it by the cosine theta as we see here. And also we divide it by the R density G. Kwa ndo formula yetu ya kuweza kutafuta hii ya kuweza kutafuta height of the tube height of the liquid in the tube. Kwa tutaconclude kwa kusema kwamba the height of the tube must be obtained by taking 2 times surface tension times the cosine theta divided by r g density. Now, from our question, we have the value of the surface tension, and also we have the angle of contact. Finally, we have the radius of the tube, and the density we have the acceleration due to gravity is constant. Sasa nini ambayo tunataka tuweze kukifanya hapa? We are supposed to turn back into our equation and take those data that we have been given and substitute into our formula. Kwa hiyo tutachukua zile data zetu tutazi paste hapa. Kwa palipo na surface tension tutaweka value yake ambao ni 3 exponent negative 2 Newton per meter. And also the place where there is the angle of contact, we should substitute it is value which is equal to 72.5 degree divided by r. R we have the value of r which is equal to 0.25. Now we are supposed to convert it into a meter kwa sababu tulikuwa tumepewa pale ni kwenye centimeter. Tukiconvert pale tutapata ni 0.25 exponent negative 3 meter. The density we have which is equal to 80 exponent 2 kilogram per meter cube. Now we times it by the acceleration due to gravity which is constant. Kwa tukisimplify pale sasa tutapata kumbe yule height of the liquid is equal the height of the liquid, my dear student, in the height of the liquid in a narrow tube or in a capillary tube is equal to 9.2 exponent negative 3 meter. Now, after obtaining, let us conclude by saying that therefore the liquid in the tube will rise up to the height of 9.2 exponent negative 3 meter above to the normal level. Kwa hiyo ndio height ambayo itafanya kile kiasi cha liquid kiweze kuongezeka baada ya kudissolve into the narrow or into the capillary tube, my dear students. So after that one, let us proceed with another example here. Our example number 6.8. Our example say that water lies in a capillary tube at a height of 2.0 centimeter. How high will the water rise at a tube with the radius of 1 side of the former tube? Here we have another example, my lovely students, and our example, as we seen, say that imagine we have the capillary tube. That capillary tube containing the amount of water. It rises at the height initially. That capillary tube, the amount of water rises at the height of 2.0 centimeter. Now, what will be how long, how high? What will be the height of the water rise to the tube if the radius of the side, or if the radius of one of the former is side, if the radius of the initial is 1 side of the former tube. Sasa swali letu kama tunapojaribu kuliona hapa, kuliangalia, anatolewa mfano kwamba we have the capillary tube, and that capillary tube, my dear student, having the amount of water. The amount of water initially tried to rise at the height of 2.0 centimeter. Now, what will be the height if the radius of that capillary tube will be one side to the former of the tube, kwamba ile radius itakuwa ni 1/3 ya ile radius ya mwanzoni. Sasa tutapataje ile height ya ile tube ya pili? This is what we have been asked on our equation here, my lovely students. As we see our solution, say that in the capillary tube, height h is inversely proportional to the radius r. We know that for the capillary tube, always the radius of the tube is inversely proportional to the radius. Kwa hiyo height anakuwa ni inversely proportional to the radius. Kwa kama ni inversely proportional to the radius, my dear student, we should say that this h is inversely proportional to r. Means when h increase, the radius will increase, my lovely students. So after this one, let us end here. We should proceed with the next slide here, my lovely students.